In this video, we're going to take a look at one of the common applications of antiderivatives, which is related to position, velocity, and acceleration. So in a previous video, we learned that velocity is the derivative of a position function. And so V is for velocity, velocity with respect to time. S is always what we use for a position function, and the derivative of the position function is the velocity function. So as an example, let's say we have a position function. And let's just say it's something like negative 2t squared plus 8t plus 5. Velocity is the derivative of the position function. So therefore, velocity with respect to time is the derivative of this function, which would be equal to negative 4t plus 8. So this is my velocity equation. And we can just condense that down and say velocity is equal to negative 4t plus 8. So remember what the position function does. The position function will tell you the position of an object at any time t. The velocity function tells you the velocity at any time t. So given a particular time, let's say at 1 unit, 1 second, 1 minute, whatever, you can determine where a particle is, or whatever the moving object is. You can determine where it is and how fast it is moving. The other thing that we learned in a previous video is that acceleration is the derivative of velocity, which means it's the second derivative of the position function. So therefore, we can say that the acceleration function is equal to the derivative of the velocity function, and that would be negative 4 in this case. So our acceleration is simply a constant negative 4 in this particular example. So acceleration being negative means that the particle is slowing down. Acceleration tells you how velocity is changing. So if acceleration is negative, that means a particle is slowing down. If acceleration is positive, that means that the velocity of the particle is increasing. If acceleration is 0, that means it's going a constant speed. So what does this have to do with antiderivatives? Well, since we understand those relationships, we can also say that therefore we can state the following relationships in integral form. Well, since the position function, or since velocity is the derivative of the position function, we can say that the position function is the antiderivative of the velocity function. In other words, it can be found by using the indefinite integral. So S sub t is equal to the integral of v sub t with respect to time. So we're working backwards. And that is, of course, as it says, because velocity is the derivative of the position function. Likewise, velocity can be found by finding the antiderivative of acceleration, because acceleration is found by finding the derivative of velocity. So these are our two inverse relationships. Velocity is equal to the antiderivative of acceleration. And so now we're going to use that relationship in a couple of problems. So first of all, the velocity of a particle moving along a straight line is given by this velocity. And so it is 4t plus 1 meters per second. Given that the particle is at position s equals 2 at t equals 1, find an expression for s in terms of t. Now, what this is basically saying is find the position function. So how do we find the position function? Well, we find the position function is going to be the antiderivative of the velocity function with respect to time. So therefore, is the antiderivative of 4t plus 1 dt, which is going to be 4t squared over 2 plus t plus c. And that can be simplified to the position function is 2t squared plus t plus c. Now you may be asking, why were we given this information? And the reason is we don't want to leave the position function with an unknown constant. In application problems, you're going to want to try to find a value for c, the unknown constant. And so they're giving us basically an ordered pair. At t equals 1, s is equal to 2. So what we do here is we can say, okay, that means when at s evaluated at t equals 1, we're going to have 2 times 1 squared plus 1 plus c. Now, s of 1 this is going to be equal to 2. And we're setting it equal to this value. So this gives us 2 plus 1 plus c equals 2. 3 plus c equals 2, or c equals negative 1. All right, so we have a c value now. And so now all we have to do to finish this problem up is plug that in for c. So s of t is equal to 2t squared plus t minus 1. And that would be the position function for this particular problem. In the next problem, it says you are standing on top of a 200-foot cliff and throw over the cliff at an initial velocity of 12 feet per second. Determine the rock's velocity. And it says, you're supposed to be throwing a rock over the cliff at an initial velocity of 12 feet per second. Determine the rock's velocity and position as functions of time and seconds. You also have to know that acceleration due to gravity, g, is negative 32 feet per second squared. That was left off of this. So there's something called the ballistics equation, which was introduced in another equation. And that says that s of t is equal to negative a sub t squared plus b sub t plus c. Now, in this ballistics equation, this is called the ballistics equation, this value right here, the b, is the initial velocity. And this value right here, c, is called the initial or the starting initial position. Initial position. So if we had an equation that looked like s sub t is equal to negative 16t squared plus 32t plus 110. What this is telling me is that the initial position of this object is 110. The initial position is 110. Now, what exactly does that mean? Well, let's just say here's the ground. Something is 110 feet above the ground, and it's throwing something up into the air, and it's forming a parabola. Right? Remember, the ballistics equation models anything that is moving through the air under its own force. It's not, there's nothing powering it or anything, like an arrow being shot through the air or a rock being thrown through the air. So the initial position is 110 feet above the ground. The 32 is the initial velocity. That tells you how fast someone threw this rock. So when somebody threw a rock off a cliff, it was at 32 feet per second. Okay, so to solve this problem, we have to kind of work backwards. Okay, so how do we work backwards? We're going to start with acceleration due to gravity. So I know that g, acceleration, g of t, is equal to negative 32. Well, acceleration due to gravity is acceleration. So it's the same thing as a sub t. So if we know a sub t, how do we find v sub t? Well, v sub t is going to be the integral of g sub t with respect to time. So that means it's going to be the integral of negative 32 dt. And so the velocity is going to be equal to negative 32t plus c. So we have an initial acceleration due to gravity, and from that we have now derived a velocity equation. However, we want to find a value for c. And to find the value of c, we have to go back to the original problem, and it says that the initial velocity was 12 feet per second. So what we're going to do is the initial velocity was 12 feet per second. That means at v sub 0, at time 0, negative 32 times 0 plus c, the initial velocity was 12. So what we end up with is c is equal to 12. So all I'm doing is initial velocity means at t equals 0. Initial velocity is at time 0. So at time 0, I have an initial velocity of 12. So I just put that into that equation. So now my velocity equation is v sub t is equal to negative 32t plus 12. Well, from that, let's find a position function. So the position function is going to be the antiderivative of the velocity function, which is going to be the antiderivative of negative 32t plus 12 with respect to t. So the position function is going to be negative 32t squared divided by 2 plus 12t plus c. And so that becomes negative 16t squared plus 12t plus c. And so now this is my position function, but once again, I need to find what c is equal to. So I go back to the problem itself once again, and it says you are standing on top of a 200-foot cliff. That's my initial position. Well, the initial position is going to go in this spot right here. So at s equals 0, at time 0, negative 16 times 0 squared plus 12 times 0 plus c, the position is, it was 200 feet, right? 200 feet? 200 feet. And so when we solve this, we end up with c equals 200. So then my full position function is s of t equals negative 16t squared plus 12t plus 200. And there is my position function. Now, if you look at this, remember what I said at the beginning of this problem? This number right here is your initial velocity, and this number right here is your initial position. And it indeed is, according to the information we were given in this problem. So this is the position function. which we used by finding antiderivatives, working backwards just from being given acceleration due to gravity.